everyone. My name is Fahad. I'm a grad student at the University of Toronto. I work in a group called the Automation of Medicine, and the goal of this group is to automate medicine through the use of technology. And one of our core values is to work and collaborate with doctors on research that can benefit people today. And lately, most of the collaboration has been with psychiatrists in the fields of mental health and addiction. The project that I work on, it's called Smokefreed, and it's related to smoking cessation. It's a chatbot that is supposed to help smokers increase their motivation to quit. Just a quick warning that this talk is more about what Elixir allowed me to do and chatbots than Elixir itself. So if you think about smokers today, what kind of help is available to them? You can think of things like going to a doctor, to a psychologist, or calling a hotline, or attending support groups, and things that are similar to that nature. All of this help is there, but you actually have to make the decision to quit before you can actually benefit from those, right? And unfortunately, the majority of smokers actually have not made that decision yet. The majority of them are ambivalent about their behavior. As much as 90% of smokers are like that. So this is a sizable chunk of smokers that we want to help. And for those smokers, the kind of help that can get today is almost by accident. So when you go visit a doctor for something else, the doctor might talk to you about your smoking behavior, or when it's too late, when you are affected by smoking and you go to a doctor to talk about that. And in both cases, the doctors don't just say, you should quit, and that's it. They use some counseling style to try to convince and motivate those smokers to quit. And one of those styles is motivational interviewing. Motivational interviewing is a client-centric counseling style that helps clients resolve their ambivalence about their behavior. It's not something specific to smoking. It was actually created to help with drinking problems more than 30 years ago. And motivational interviewing revolves around 4 concepts or 4 principles: open questions, affirmations, reflections, and summaries. So when you're trying to deliver a counseling session using motivational interviewing, you have to think about those. And there are many techniques that you can deliver motivational interviewing. The one that I use in the Smokefreed project, it's called a running head start technique. And the running head start technique basically asks you what is good and bad about the behavior you're doing. And it then asks you some follow-up questions to basically elicit reflection and change talk. So let's look at an example of a motivational interviewing conversation. Imagine a doctor asks what is bad about smoking. So that's an open question. And then the client might reply, when I'm out of cigarettes, it is torture until I can get more. So the doctor then at that point might take the chance and say, I understand you crave smoking and find it addictive. So we've established reflection here. We've confirmed that we understood what the client is saying and reflected that back. We also have another chance to say something like, I appreciate you talking about your cigarette cravings. It takes courage to admit that. And that's a form of affirmation. So we want to basically encourage and motivate the client whenever there's a chance to praise some behavior that they did. And then the conversation might go on, and the doctor will say, let me summarize what you've told me. And then the doctor will say exactly what the client told them, and then what they believe it is. So at this point, we also achieved summarization. And motivational interviewing has been actually very successful. It's been successful when doctors use it in personal sessions, when you talk with a client face-to-face. It's also been successful when it's used in conjunction with other help, like attending support groups. And actually, research has shown that for people who attend support groups and receive text messages and emails after they leave the support group, and these text messages and emails follow motivational interviewing, that helped them sustain their basically quit status. And when you think about it, actually, motivational interviewing is very open-ended, but it has some structure. And in the medical industry, actually, there are some protocols and standards that you can use to evaluate if a conversation follows motivational interviewing or not. So maybe we can do to this open nature, maybe we can, and some structure, maybe we can use chatbots to teach a chatbot how to use motivational interviewing. And if chatbots have a lot of potential, they can actually help a lot of people at scale. We can just have a chatbot running online, and a lot of people can interact with it. So we can have it in popular chat platforms like Facebook Messenger or Kick Messenger. And what that allows us to do is reduce the cost of actually finding help, like finding doctors or support groups, and reaching people where they are. And if you think about what a chatbot is, a normal chatbot workflow would be to first get an utterance, and then you try to make sense of this utterance by extracting meaning out of it, and then selecting a response based on this meaning, all the while keeping the conversation context. So you need to keep the conversation context and not just work on an utterance by utterance basis. And before I actually started building this chatbot, I wanted to know if anyone actually has done something similar to what we want to do with Smokefreed and motivational interviewing. And I found one famous example. It's actually the Eliza dialogue system. And Eliza was invented by Joseph Weizenbaum at MIT AI Lab. And similar to what we want to do, Eliza mimics a Rogerian psychologist. So Rogerian psychotherapy is a counseling technique that is similar to motivational interviewing, but it's mostly about reflecting what you say and showing empathy where it applies. And so it doesn't try to actually make you or encourage you to say things that will elicit change. And the way it worked, it basically used a collection of pattern matching rules, and each rule that will match an utterance has an associated rule that will generate a response based on that utterance. And I want to show you an example of a very famous conversation between the Eliza system and a young woman. So I'm going to play in audio clips, and the computerized voice is the Eliza system, and I'm going to read the transcripts of the young woman.
Good evening. Tell me your problems.
Men are all alike.
In what way?
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
He says I'm depressed much of the time.
I am sorry to hear you are depressed. Who else in your family takes care of you?
My father.
Your father.
You are like my father in some ways.
What resemblance do you see?
You're not very aggressive, but I think you don't want me to notice that.
What makes you think I'm not aggressive?
You don't argue with me.
Why do you think I don't argue with you?
You're afraid of me.
Does it please you to believe I'm afraid of you?
My father is afraid of everybody.
What else comes to mind when you think of your father?
Bullies. So if we examine this conversation, it actually was a good conversation, and it had a great deal of reflection from Eliza. And you can feel that person growing attached to the machine and actually having a therapeutic experience with it. And this is not the only example. Eisenbaum, the inventor of Eliza, was talking about his secretary, and she tried Eliza a couple of times, and after that, she wanted him to actually leave the room before she starts talking with Eliza. So she also grew attached to the Eliza dialogue system. And what's most impressive about this whole work, that it was actually created more than 52 years ago. So imagine what we can do with today's technology if more than 50 years ago people were able to help others in the mental health space using chatbots. So Eliza did work on some people, but it had some problems. One problem is that it's really hard to enumerate all possible rules. So for everything that Eliza generated a response on, right, it had an associated rule with it, right? And it's just not feasible to enumerate all possible rules. And it also required that you have good structure and good grammar in your sentences to match the rules that exist in it. And the last problem, that it did not keep any conversation context. It was almost an utterance by utterance basis. So one potential solution that we can do is we want something that accounts for unseen utterances. So we don't want to specify all the rules. And we want something that accounts for poor sentence structure and bad spelling. And because we know that almost everyone online does not know how to spell. And also, we want to keep the conversation context. And when you think about the first two problems, machine learning comes to mind. Maybe we can use machine learning to solve these problems. Because in contrast to using specific rules, machine learning allows us to generalize over unseen events by using some training set and learning patterns from that, and then we will generalize over unseen events. And it also, that applies to sentence structure, because we will be training on sentences with bad structure or even misspelling. So we can account for that and generalize over it. But machine learning does not solve the keeping conversation context problem. And the process of using machine learning to extract meaning out of utterances is commonly known as natural language understanding. So for example, if you have an utterance like, I don't like the smell of smoking, you might have natural language understanding that determines that the reason that you don't like smoking is smell, and might detect that the sentiment in this utterance is negative. And another example might be, I appreciate you helping me, and we will have some natural language understanding that detects that this person is trying to say thank you, and the sentiment is positive. And when you think about our initial chatbot workflow, we would replace that extract meaning step with the natural language understanding and use machine learning in that step. But we want to be able to select responses based on the meaning extracted using natural language understanding. And to actually solve that, we need to use state machines, or one option is to use state machines. And I'm assuming everyone here knows what a state machine is. So imagine that we have a conversation like the following, where the doctor asks the smoker if they smoke, and then asks them what's bad about smoking, and then summarizes that. And we want to use a state machine to basically group the conversation into basically points at which you're looking for specific things, right? And you kind of enforce some constraints and grouping of related things. And we can actually take this conversation and map it to a state machine like the following. We will have a state that asks if you smoke, and then a state that asks what's bad about smoking, and another one that summarizes everything that is bad about smoking. So, and if you think about state machines, the transitions between states and the fact that you're in a given state, this is how you keep conversation context. To make this point clear, imagine that we exercise the no path here when you answer no to do you smoke. So we go to the summarize state, and because we know we haven't passed that what's bad about smoking state, we have a conversation context, and we know that the client has not said anything bad about smoking, and we can reflect that in the conversation. Okay, so after I decided I want to use natural language understanding to extract meaning out of utterances and use state machines to keep the conversation context and generate responses, I went and looked out for open source chatbot frameworks that I can use. And I've used a couple, but I reached dead ends very quickly, actually. And the problem with that is most of these things require you to use specific DSLs or data files or build your chatbot over a graphical interface, and it just becomes very hard to build complex chatbots. They might be simple or okay. It might be okay for you to use those to build basic command and response chatbots or simple chatbots, but it wasn't like that in my case. So most of them were very inflexible and really hard to customize. So that's why I came up with my own small library that will help me in building chatbots, and I called it BotKit. So BotKit is an Elixir library that helps you build chatbots if you want to go with using state machines to keep the conversation context. And in BotKit, we don't have DSLs or data files. It's just modules and functions like you're used to in Elixir. It's actually just a couple of behaviors that you have to implement to have a chatbot process. Similar to what Gen servers and the other things like that follow process architecture, chatbots here are processes, are independent processes. And the only difference is that a BotKit chatbot process might actually span multiple modules, multiple Elixir modules, if you have multiple states in your conversation state machine. And also BotKit uses the concept of pipelines. So whenever you get an utterance, you have to pass it through a pipeline that effectively acts as your natural language understanding step, right? You want to extract meaning out of it, and then it'll take the result of the pipeline and pass it to the state that your conversation is in, and based on that, you will generate a response. I've said that in BotKit, you have to implement 2 Elixir behaviors. And the first one is the bot behavior, which is the behavior that is responsible for managing the process, like initializing it and terminating it, and as well as specifying the pipeline I was just talking about. And the other behavior is the bot state behavior. And the bot state behavior basically is a behavior that you must implement on each state in your conversation. And what's required here is that you have a pipeline callback in your bot behavior, and you have a on callback in your bot state behavior. And you can see here that the on callback will take a pipeline result and will return this chat struct. And also this chat struct will be given to the callback. And the best way to explain what this chat struct is to think of it as something similar to change sets in Ecto or connection structs in Plug and Phoenix. So if we think about our chatbot workflow in the context of BotKit, right, we would replace extracting meaning with the pipeline callback and then generating responses with the on callback. Unfortunately, I don't have enough time to demo to you both the BotKit, the framework, or the library, and show you the Smokefreed chatbot that I've been building. So I'm just going to show you the Smokefreed chatbot. So Smokefreed is actually online and deployed online. And we have had actually some people try it and help us with it. So the first thing is that you have to read this disclaimer and agree to start talking with the chatbot. So let's do that. So this is actually a web app that is using Phoenix channels to talk to these chat processes that I mentioned in BotKit. So you see these dots indicate that the bot is writing something, and we've added this to basically simulate a human writing experience, and we found out that the users of the bot actually like that. So it'll introduce itself to you, tell you that it's from the University of Toronto and CAMH, which is the Center of Addiction and Mental Health in Toronto, and then basically ask you for your consent. So let's say yes, we want to talk. Okay, then it's going to ask for this prolific ID. Just don't mind that. That's something that we require out of our participants so we can actually use their data. So also the bot has this feature where it will actually offer you option bubbles for you to choose from. So let's say yes, we confirm. So as I said before, that this chatbot uses the running head start technique, where it will ask you about good and bad things about smoking. But we first need to ask you if you do smoke and if you do like to smoke. So let's say yes. And the reason for asking why you like smoking is we want to know which open question we should start with, the bad things or the good things. So if I say yes to if I enjoy smoking or not, then we'll discuss the good things. So the first thing I say, it makes me feel good. So I purposely misspelled this to show you that using machine learning, we can generalize over spelling mistakes. So the bot replied with saying, I understood, it makes me feel good, as something related to feeling good. And the chatbot right now is actually in training mode. So every time it extracts meaning out of the sentence, it will try to confirm it with you. And that's how we actually keep training the bot to be better. So let's say, OK, you were right. So then it offered reflection and affirmation by thanking me and also reflecting that statement of feeling good about smoking. So it's going to ask me what else is good about smoking. Let's say I like to smoke. So I'm purposely misspelling here. I like to smoke when you use internet words, friends. So it actually, at this time, it did not get that right, and it characterized it as something related to physical appearance, so we want to fix that. So let's say you were wrong, and so it will give me all the possible options of the reasons it knows about why smoking is good. So let's say that I meant socializing when I said this. So again, affirmation by thanking me, and it asks me if I have something more. I'll say that is it. So we also have something that looks for if you are trying to communicate that you have nothing more to say, and it's confirming that, and you say you're right. So we've discussed the good things, and at this point, the bot will try to summarize everything that I've told it. So it said when it makes me feel good, I believe that's related to or be classified as feeling good. And the other one, when I said I like to smoke, when I'm out with friends, as socializing. And keep in mind that the first detection it got was physical appearance, something related to physical appearance. Because I have trained it, it was able to correctly convey that later in the conversation. So it's going to move to what's bad about smoking. And let me show you. Let's say it is a fire hazard. So at this point, the bot did not understand. So initially, we saw it making a correct detection. and then we also saw it make a wrong detection, and now we saw no detection. So the workflow for dealing with situations is like that, is to basically ask the user to say it in a different way. So let's keep, let's say something similar. I think it is a fire hazard. Oh, not very creative, but I want to show you the point of this. So it gave you a chance for you to say it in a different way for it to try to understand it, but if it doesn't, it will just tell you, okay, just tell me what you mean by this. And we don't have anything related to fire hazard in here, so I'll say other. So it'll ask me if I can say a few words about it. Let's say it's fire hazard. So the good thing about this workflow is that whenever someone has something new that we were not accounting for, we can actually get that from them. And all of this is enabled by using state machines in the BotKit library. The conversation actually can take very long. The shortest conversation we have on record when people tried it is 7 minutes, and the longest is 1 hour and 40 minutes. So I'll just move back to my presentation. Okay, so what is the status of this project? Right now, Smokefreed is actually, we're still working on it. And if you look at what we wanted to do, we wanted to build it, then train it, and then actually deliver it to someone and deliver the intervention of trying to motivate smokers and measure the effect of that. And at this point, we're at the end of the training stage. And the good thing is that stage 1 and 2 are the most involved stages in this project. And as soon as we finish training, we can do 3 and 4 in actually short times. And also, I want to mention that because we are dealing with people and we're trying to run experiments on people, it's really hard to run these experiments. You actually have to get ethical approval from, or ethics approval from the board of the university. So we had to get that. We had to get one for training and one for actually delivering the intervention. The one for delivering the intervention is still ongoing. We haven't received that yet, but hopefully we will in the near future. Nevertheless, I have some results that I want to share with you. So we trained it on 26 people. 22 of them were actually smokers that we've we've recruited. And so we've trained it on the first initial 4 people, and we had 11 smokers out of the 22 one try it. And we've measured the accuracy of the bot. And the first time we measured it on the first batch of smokers, it was getting things correct 59% of the time, things wrong 4% of the time, and then missing meaning 37% of the time. And then we've trained the bot with the first 11 smokers and what they've told us in the conversation, and we were able to increase the percentage of the time it got thing right to 68, and lower the time it got things wrong to 2, and 30% lower the missed one to 30%. So just to repeat, the difference between wrong and missed, wrong means that you thought that there is meaning, but that meaning was wrong in the sentence, and missed means that there was meaning, but you were not able to call it. And we actually were thinking we should try it on a couple of 100 people, but we will try to keep this training process until the point of no diminishing returns, where we don't see the right percentage increase or the missed go down. So we've also asked the 22 smokers to give us general feedback after they finished talking with the bot, and the majority of them said good things, and only one person actually said negative things. But don't be fooled by this 50%, because we're not sure if it is because the chatbot experience was good or it was effective in increasing their motivation to quit. And that is something that we will address when we move on to the intervention stage, where we ask more questions and try to differentiate between those things. So I'm going to show you some of the feedback we got. The first feedback we got is this person who said that was actually really very helpful. It was getting my thoughts out. I have been smoking for a long time, and this was the first time, believe it or not, that I actually got some insight into my behavior. Loved it. So imagine working on this project for more than a year and not knowing if it will work or not. So this was the first feedback I got, and I remember getting goosebumps because I realized that this was helpful to someone. And some other person said, I like that the system got me to think about the reasons I enjoy smoking and the reasons I do not. I was able to see that there were more reasons I dislike smoking. So we offered this person some kind of reflection. Another person said, it did make me think about my motivations, etc., for smoking. It was interesting, and I think I did find it quite helpful, actually. Just the act of having to spell out things that usually are automatic, subconscious, really makes you realize how daft a lot of it is. Glad I got the chance to try it, giving me some food for thought, thank you. But not all the feedback we got was positive. One person said, frustrating, the questions made little sense, a lot of self-reflection kind of felt pointless as well. I smoke a pack a day often without thinking about it, so pinpointing a time when something caused me to smoke is really hard. So this was the only person who said negative things about the chatbot. To me, actually, if we remember, we're dealing with 90% or more than 90% of ambivalent smokers, and if we just help as low as 5% of them, that's an achievement personally. So as long as someone is benefiting from it, we want to keep pushing. And some people, I don't know what kind of feedback this is, maybe they're trolling us. This person said, it could be made more attractive, maybe with some sounds, possibly a funky chat bubble. Okay, so I've talked about chatbots and the Smokefreed chatbot, but not a lot about Elixir other than the BotKit library. So I made the decision to use Elixir 2 years ago into going into this project, and I really feel good about that decision. And one of the reasons why is it's really easy to build chat apps with Elixir, right? Because of the whole process model and things like Phoenix channel make it so easy to build chat apps. And also, the Elixir and the underlying Erlang VM is actually give you a lot of fault tolerance guarantees. So I mentioned that BotKit uses processes for each chatbot chat, and in Smokefreed, those processes are supervised. So I only worry about the happy path, and I embrace the let it crash philosophy. And so whenever that process crashed, the supervisor would restart it, and that process was keeping state and persisting it into an external storage. And so it was able to start from where it left off whenever it crashed without the user knowing anything about it and without me having to deal with it. So it's actually a very good experience. And also, one thing that not a lot of people talk about in Elixir and the Erlang ecosystem is that there is always an escape hatch if you don't find what you want in Elixir. So, for example, there's not a lot of machine learning libraries that you can use in Elixir or Erlang in that matter. But I was able to use an Erlang node running a JVM instance that has all the natural language understanding functionality. And even for fun, I used Kotlin to do that. And all of this was enabled by this ecosystem. And there are many options. You can use NIFs, you can use ports, you can use C nodes, you can use Erlang nodes. There are many options that you can use to talk with the outside world. So I really like Elixir, and I'm happy about the decision I made 2 years ago. And just before I end, I just want to thank Professor Jonathan Rose and Dr. Peter Selby for giving me the chance to work on this interesting project and helping me and supporting me for the past 2 years. And if anyone here has questions, please come find me after the talk. Thank you.